So this video is my response to the SpaceX challenge levied by STEM Coding. I'll have a link to their videos about this in the description below. But basically the challenge is to get a rocket to land vertically here on the Earth, where we have a gravitational field of 9.8 newtons per kilogram. This challenge is pretty straightforward when we try to land on the moon that has a G value of about 1/6 of this. But when you try to do it here on the Earth, you end up, you can get it to land, obviously, but you're landing with a speed of about 17 meters per second. For reference, normal human walking speed is somewhere between 1 to 2 meters per second. So this is not a very good landing speed. This is a good way to ruin your rocket. And basically you have to hit play and then start exerting the thrust upward as soon as possible. You don't get any brakes from it. This time I clicked soon enough, and I got it down to a velocity of just under 10 meters per second, so that's a little bit better. But of course, part of the issue is that we've left the thrust at 30, and this is the amount of thrust you would need in order to land this thing on the moon, where G is 1/6 of this value. So the cheap way to do it would be to multiply this thrust by 6. Oops, and then we can actually, a little too much, we can actually get it going back up into the sky. Yeah, that's a little bit much there, Brian. So clearly that's not an acceptable value either, because the controls are now too sensitive. Yeah, I ended up landing with a velocity of 26 meters per second anyway, geez. So the trick is then to adjust this fraction to be somewhere in between 1 and 6. Let's go with halfway there. Let's go with 3. Okay. Landed with 14. Okay, so yeah, I'm still, I would like it to not be launching back upward. So multiplying by 3 is too much. Let's try just multiplying by 2. Let's run this. Yeah, I'm still getting a little too much. Now, of course, part of the problem is I'm a human trying to control this. So the best way to do this would be to get the computer to do this for us. So let's see if we can get the computer to worry about whether we are implementing the whether or not we're implementing the thrust. So what I can actually do is take this system here that we've got set up where we are exerting the thrust. Now this is currently registering for whether the up arrow is being pressed. Let's try to get the computer to do this for us. I'm going to just take these and copy and paste. And basically what I want to do here is have the computer determine whether it should be applying the thrusters. So I need for the computer to be thinking about the vertical velocity. So let's try let's see, what are we using for vertical velocity? We're calling that Vy. All right, so let's try if Vy, guess I don't need a space there. If Vy is, let's say, less than, let's see, we don't want this thing landing too terribly fast. So let's say if Vy is less than -1, then we want it to apply the thruster vector. Here we go. Now I'm not going to have the computer rotate, but I'm just going to go ahead and leave this cosine theta sine theta stuff, even though theta is going to be locked in at being vertical. So let's see what happens with this now. And so you see, we end up with the thrust being basically toggled on and off by the computer. And so our velocity is going anywhere from, looks like 0 to -1, basically. And so it's going to take a long time for it to land, but we can basically get it hovering over this thing. So that's probably a little too much. Let's give this a little bit better window here. Because the thing is, it can be falling faster. It just needs to be going slower when we reach the landing pad here. So probably what I need to do is make this maximum velocity, or minimum velocity in this case, dependent on how far away we are from the landing barge. So let's see, where are we starting at in terms of height? We start out at 250 above. So going from, where does it start out? So going from here down to here is about 250. So probably at about, let's say 50 from the bottom. So 1/5 of the way there is the only time we need to worry about this. So let's try if y is less than 50, and Vy is less than -3. So if it's too close to the barge and going too fast, see what happens there. See, it leaves it alone. Oh, and that was not enough. Okay. Oh, wait, where is the barge? Actually, I should probably find that out. No, yeah, the barge is at 0. So that did not turn on soon enough. Let's see. Let's go with y less than 100. Okay, that was not soon enough for it to turn that on. All right, let's try 200. Maybe I'm misunderstanding the scale here. There we go. Now it's starting to flicker on and off. All right, so maybe I need to do some stages here. So for example, I don't need it traveling that slowly there. So what I could do is set up a bunch of conditions here. Why don't we try doing it this way? Let's make a new logical variable. Turn on thrusters. And we're going to call, let's see. So we're going to have this be dependent on both the location and the velocity. So let's try if we're less than 200 and our speed is less than, let's say, let's go with 20. Or, is that how I type an OR here? I don't think that's how I do an OR here. OR is probably, let's see, this is what? This is JavaScript, I think. So what is OR in JavaScript? Comparison of logical operators, equals, not equal, greater than, less than equal to. Yeah, I need the booleans here. Come on. Okay, there we go. Oops, I need 2 vertical bars. There we go. So we're gonna try. Let's see. Let's try a little adjustment here. So now I can make this lower. So if y is less than 100, and at 100 I need this to be a little bit slower. So let's go down to 2. And then I need an OR. Copy. Oops. Let's move the scroll bar over. Paste. Let's go down to 50 and say it's got to be less than 1 in terms of the speed. Okay. So now what I need to do is I'm letting this take care of all the details, and here I just need to have if we're supposed to turn on thrusters. All right. Let's see if I've set that up correctly. Oh, there we go. There we go. All right, so we're getting a little too... It's taking a little too long there, I think, because you don't want to have this much fuel loaded, or else we're going to increase the mass too much. So let's actually give another indicator here of what our height is, because I don't have an intuitive sense of what the height is on this scale. Let's see here. So I now want this to be y. And let's see, I need to move this down another notch. So I moved this down by 0.05, so let's move this down to 0.65. Move this down to 0.65, and we're going to display y. All right, so show me where I'm reaching each of these. 40, 90, 80. Okay, so we're going a little too slow once we reach about 60, I think. So I can actually probably lower this thing to be, maybe make this 75 and make this one. Okay, so here where it stops is about 15, so that's good to know. So let's make this about 45. Let's see what we can get in terms of an impact velocity. Yeah, here we're basically hovering and we're just above the stopping point. So here we get, I'm not sure what's happening here where I get a velocity of 0, I land on the barge, but the code isn't finishing. Maybe I have something wrong with my game over condition. Oh, if y is less than 0. Maybe we need to make that less than or equal to 0. Let's try that. Because I've had that happen a couple times before. But I can visually tell when the game is over. Okay, so I can have it go a little bit faster there. All right, so let's have... Maybe we can change... Maybe we can up these a little bit. Maybe we can increase this one to 3 and this one to 2. All right, Vy less than -2. Yeah, so let's try this. Well, but anyway, that's the kind of structure we would need to get this thing to automatically land safely, would be to keep track of both the height and the speed. And basically now it's just a matter of fiddling with these numbers until we get an appropriate landing time and landing speed. So I have answered the SpaceX challenge. I will be passing that along to some of my YouTube buddies. Thank you so much for watching, and thank you STEM Coding for the fun challenge. I will see y'all next time. Bye-bye.